Today we are going to see about the electrical network types and circuit terminology. Let us see first what is mean by electrical circuit or electrical network. See, an electrical circuit is nothing but an interconnection of electrical components together in order to perform a particular task to get the desired output. The component may be batteries, resistors, inductors, capacitors, switches, transistors, or it can be an voltage source or current source. But see, let us see the basic properties of electrical network one by one. Whenever we are using any electrical network or circuit, it should provide a closed path so that your electrons can flow and it will complete the circuit. See the second point, a circuit always consists of at least an energy source. A circuit without an energy source, it will not able to provide a source of electrons. So that it should contain at least one energy source. That energy source may be an voltage source or current source, whatever it may be. Coming to the third point, the electrical elements include either the uncontrolled or controlled source of energy, that is voltage or current source, then resistors, capacitors, inductors, etc. Next, we are going to see about the types of electrical networks. Coming to the type, first we will see the linear circuit. Whenever a circuit whose parameters, like the parameters in the sense the measured quantity like temperature, pressure, voltage, current, resistance, capacitance, whatever maybe, these are all the parameters which we are getting from the circuit. So it is a circuit whose parameters remains constant with change in voltage or current. Whenever there is a change in voltage or current, your parameter should be remains constant. So this is an example of the linear circuit. The examples are resistance, inductance, capacitance. See the graph here. This is nothing but the output of linear circuit. Whenever your voltage increases, your current also increases, but it increases in a linear fashion. That is, it keeps on increasing like a straight line. So it resembles a linear circuit. Coming to a non-linear circuit. Next, non-linear circuit, that is the circuit whose parameters will change with respect to the voltage or current. Whenever there is a change in voltage, your parameter is also changing. An example is nothing but a semiconductor device, that is diode. Diode is the best example of the non-linear circuit. See the graph here. Whenever there is an increase in current, your voltage also increases. But this increase in voltage is not like a linear fashion. See, in starting it is linearly it is increasing, then suddenly it forms a curve and it is increasingly sharply. So this is the output is nothing but a curve like fashion. It doesn't fall under the linear like fashion. So this comes under the non-linear circuits. And third point is a linear circuit always obeys Ohm's law. That is, the current remains directly proportional with applied voltage, while in non-linear circuit the Ohm's law is not satisfied. That is, what is meant by Ohm's law? Ohm's law is nothing but V is equal to I into R. That is, V is directly proportional to your current. Whenever there is an increase in voltage, your current is also increases. Therefore, the output is also linear like fashion. But in case of non-linear circuit, your Ohm's law is not satisfied. Next one, unilateral circuit. That is, whenever the direction of current is changed, the characteristics or properties of the circuit may change. This is nothing but an unidirectional circuit. Unidirectional circuit is nothing but the flow of current, that is the path of the current is valid only for one particular direction. It is not possible in both directions. Let us take the example of diode or a transistor. In this diode, during the forward bias, that is from P to N type, that is in forward bias alone, your diode will conduct, but whenever you change the direction of current from N to P type, that is reverse bias, your diode will not conduct. That is, your current will flow only in one particular direction. Therefore, this circuit is called as unilateral circuit. Coming to bilateral circuit, that is, when with change in direction of current, the characteristics or properties of the circuit may not change. It is called as bilateral circuit. The best example is resistor. Since the resistor is having both the ends, in either end the current can flow. That is, the current can flow from right to left. Also, the current can flow from left to right. Whatever may be the direction of current, your circuit property will not change. So, mostly elements made of highly conductivity materials are bilateral circuit. The best example is here resistor. Next one, active network. It is a network which contains one or more than one source of EMF. That is, active network is nothing but a network which provide energy source. It consists of an active element like battery or a transistor. That is, it is an energy donor. Active network or active elements are mainly known as energy donor. It will provide the energy. But in case of passive network, it does not contain any energy source. Instead, it contains some network of elements like resistor, inductor, capacitor, which will accept the energy from the active network. So passive network is also known as, or passive elements is also known as an acceptor, that is energy acceptor, while active elements is known as energy donor. Passive elements is also known as energy acceptor. The elements which is used in a that is the passive elements which is used in a network is known as a passive network. Lumped and distributed network. Networks, that is elements which are physically separated like resistors, inductor, capacitor are known as lumped elements. But a transmission line, we can see the transmission line like a single phase transmission line or a three-phase line, whatever it may be, or a cable. It is an example of a distributed network, since throughout the length of the line your resistance, inductance, capacitance are distributed in nature, where they cannot be separated. Like let us take the transmission line, that is a single phase transmission line coming to your home. It is coming from the post to your home. Inside the transmission line, your inductance, resistance, capacitance will be combinedly mixed together, and it forms a distributed network. When it is physically separable, like when we are able to separate the resistance, inductance or capacitance, then it becomes a lumped network. If it is not possible to separate the elements like resistance, inductance or capacitance, then it becomes a distributed network. So your transmission line as well as your cable is the best example of your distributed network. Next, recurrent or non-recurrent network. When a large circuit consists of similar network of one after the other, that is, suppose if I am taking a circuit which consists of a voltage source which is seriously connected with a resistor, inductor, capacitor, a similar kind of circuit is connected again one after the another, that is cascading, then it becomes a recurrent network. When a single network alone is present, then it is called as a non-recurrent network. I hope I have cleared the definition. Recurrent network is nothing but a network, a similar kind of network will be appear one after the other. That is, multiple times a network is repeating, it becomes a recurrent network. But instead of multiple times, a single network is present in a circuit is called as a non-recurrent network. Next, we are going to see about the circuit terminology. An electrical circuit is also as an electrical circuit or electrical network, whatever it may be. It is based on three concepts, namely a node, branch, and a loop. So a network may or may not be provided a closed path to the electrical current to flow. That is. So the electrical circuit may be a combination of one or more networks, but it should provide a closed path for the necessity of current flow. That is, in order to make the current flow through the circuit, it should provide the closed path. Next definition is node. The node is nothing but the point through which the circuit element is connected to the circuit. That is, two or more elements are connected to a particular point is called as a node. See this circuit here. Every node is represented by a dot. Here the voltage source as well as the resistance R1 is connected by means of this node. See here, this R1 and R2 is connected by means of a node here. How many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8. Totally 8 nodes are present. So easily we can get the definition of node. A node is nothing but a point through which a circuit element is connected to the circuit. That is, more than two or more circuit elements are connected together to form a junction. A junction is also known as a node. See here, two elements are connected, that is R1 and R2 are connected by means of this node. Here, this line, that is the wire, and as well as the current source is connected by means of this node. Next one, branch. The branch of an electrical circuit can be defined more precisely as the portion of the circuit. See, here the resistance, this R1 is nothing but a branch. Here, this R2 is nothing but a branch. Here, R3 is nothing but a branch. Here, this voltage source is a branch, and the current source is a branch. But this segment, this is not a branch. Since this is a wire without any element. So an element which is present between the two nodes is also called as a branch. See here, this is one node and this is one node. These two nodes are interconnected by means of this voltage source. Hence, we can call this voltage source as a branch here. Similarly, this is one node and this is another node. Here, between the two nodes, a resistance R1 is connected. So, this R1 forms a branch. Next one, loop. A loop is any closed path in the circuit formed by many branches. Here, if one starts from one node and after going through the set of nodes, it returns to the same starting node, which constitutes a loop. Let us see here. Let us start from A. Then it goes to B, then it goes to E, then it goes to F, and finally it reaches again A. So see the blue color arrow mark here, the loop A, B, E, F, A. From where we are starting, that is the ending point. From A we have started, we have moved through B, E, F, and finally we have reached again the starting point, that is A. So it constitutes a loop. Then a second loop, B, C, D, E, and B. This forms a loop. Then again A, B, C, D, E, F, A. The line which is indicated by the red color, it forms a third loop. So this circuit consists of three loops. First portion is A, B, E, F, A. The second portion is B, C, D, E, B. The third portion is we can combine the two loops and we can form a single loop, that is A, B, C, D, E, F, and A. So finally, three loops are present in the circuit. Next one, mesh. If the loop in the circuit does not enclose any other loop inside it, then the loop can be called as a mesh. What it does mean? That is, a single loop can be called as a mesh. A mesh should not contain two loops inside. So here this first arrow mark, that is within the I1, it is one mesh, and this I2 forms a second mesh, I3 forms a third mesh. What is the difference between the loop and the mesh? See, in the loop, a single loop can contain two loops inside this. See the red color loop here, it contains two blue color loops, but in case of mesh, it should not be there. That is, it should not contain two loops inside this. So we can say a loop can have multiple two loops inside, but a mesh should not have any multiple loops inside the mesh. So the mesh can be a loop, but the loop can't be a mesh. Clearly find the difference. A mesh can be a loop. What does mean by a mesh can be a loop? See here, this is mesh 1, but it also forms a loop here. But in case of a loop should not contain a mesh. Since within a loop, two or more loops can be present. So see the statement clearly. The mesh can be a loop, but the loop can't be a mesh. See the circuit here. The blue color line which represents the loop. See, a loop, within that loop another one loop is also present, but the red color symbol represents a mesh. So there is three mesh, and the green color portion represents the node, that is A, B, here it is D, here it is E, F, G, and H. So the green color portion represents the node. As I have already told, the node is nothing but at one or more elements meeting at a particular point, which is represented by a dot. A loop is nothing but from where we have started, that is the starting point, and that should be the ending point. But the loop can contain more than one or two loops inside the particular loop. But the mesh is a single loop. The mesh should not contain more than one loop. That is called as a mesh. So these are the common DC circuit theory terms, which I have already told. The circuit, a path is nothing but a single line of connecting elements. A node is nothing but the junction which is represented by a dot. A branch is a single or group of components such as resistors or source which is connected between the two nodes. Whatever may be the component which is connected between the two nodes, which constitutes a branch. A loop is nothing but a